Hello, welcome to the Keyence IX training module. Today we'll discuss how to set a position adjustment tool, when you should set one, and the best practices for using the tool. The position adjustment tool is unique compared to other tools available on the IX. It is used to adjust the position of other tools by searching for a shape specified in the registered master image. As seen in this example, if the identified shape rotates, the measurement point of another tool will shift along with the position adjustment tool. This tool is best used in applications where the part's position under the sensor is not repeatable. Today we'll talk about how to use the position adjustment tool in scan mode. In scan mode, you'll first complete your detection setup and master registration. Then it's time to add our tools. In this example, I've already added a simple height tool. This is necessary as you cannot create a program with only a position adjustment tool. For more information on the height tool, please see the dedicated height tool video. Now let's add our position adjustment tool. Click Add Tool, select Position Adjustment, then press OK. A square outline will appear on screen. This is our position adjustment tool. You can see within our tool certain elements have been highlighted. These are the edges detected by the sensor that will be used as our position adjustment. Let's discuss best practices with the position adjustment tool and where we should place our tool for a part like this. By default, the tool will load in the center of the screen, highlighting the 4 circular pieces of our demo piece as well as the line down the middle. This may be a serviceable position adjustment, but let's say we're only checking the height of the top left circular feature. If a part comes through that's missing its bottom right circle, we don't really care about that for the purposes of our inspection. However, if we're missing that circle, the position adjustment will fail and we'll end up rejecting the part, so choosing the proper placement of this tool is very important. The best practice for placing your position adjustment tool is to place it on a unique feature that is only seen once each time the sensor scans. For example, it may seem like a good idea to place it on a single circle on this part. However, there are multiple circles for the tool to choose from. If we hit Test here to view a live image of the sensor, then move the tool around, you'll see it locks on to a different circle than the one we initially specified, which will throw our other tools off as well. Even when it finds the right circle, the tool rotates, meaning it will move the position of our other tools in accordance with its rotation. In general, a circle does not make for a great position adjustment. With this piece, the best placement of our position adjustment tool would be the bottom edge and corners of the part. Often a corner of a part will make for the best placement as each corner has its own unique shape. To make this even cleaner, we'll click Remove Outline to remove some of the noise the sensor is picking up. Often the sensor will see edges that we don't want to include. The roughness on the metal part of our piece is causing the sensor to detect some edges there, so we can click and drag our eraser tool over these edges to remove them. Removed edges are marked by a yellow outline as opposed to a green one. We'll also erase the middle line as we're really only concerned with finding the bottom edge and corners. Once we've removed the extra edges, we can click Close. Let's discuss the available settings for our position adjustment tool. First, you have the option to change the shape of the tool window between rectangular and circular. You can also set a partial search region. By default, the sensor will scan the entire field of view to find the selected outline. By selecting partial, we can tell the sensor to only search within a certain section of the field of view. The partial search region is represented by the light blue rectangle. Clicking Angle Reset will reset the angle of your tool window if you've rotated it. We also have some settings to fine-tune our outline. We've already seen how Remove Outline works, but we can also change our sensitivity, which determines how sensitive the IX will be when extracting outlines and edges. You can select between high, middle, and low, and you can see how the extracted outline changes as we switch between the settings. Limit Adjustment allows you to change the threshold at which the tool will give a no good judgment. By default, the tool will need a matching rate of 70 or above to give an OK judgment. Matching rate reflects how closely the tool's measurement matches the shape outlined during setup. I'll click Test to show how this works. As you can see, we usually get a matching rate close to 100, but if I cover part of our outline feature, you'll see the matching rate drop. If I cover it more, it drops below our threshold and gives a no good judgment. Now I'll click End Test, and let's click Extended Functions to see the other settings. In Extended Functions, you have the option to set your rotation range from 0 to 180 degrees. At 0 degrees, the tool will not rotate at all, meaning the outline feature will have to appear in the same precise orientation each time the sensor scans. At 180 degrees, the tool will rotate all the way until it's upside down, allowing for a high degree of flexibility for part orientation. You can also choose to turn the margin on or off. As explained in the software, turning this on means the tool window will rotate a bit more than what you set it for. Turning margin off will only allow for the exact degree of rotation you set. Your search algorithm is selectable between high speed and high accuracy. High speed means the tool will detect the outline quicker. High accuracy means it will detect the outline with greater accuracy. That's all our available settings, so let's click OK. Now we can press next to step 4, and because our outputs aren't relevant for this video, I'll click complete settings, and then yes. Now that I'm back on my main screen, I'll put the sensor in run mode to show you how the tool works in conjunction with our height tool. As you can see, as I move the part around, the sensor is still able to accurately read our height tool even as our part orientation changes. Thank you for watching.